Hello everyone, welcome to Spark Study. In this video, we'll study about some problem related to Bode plot. We have studied what is Bode plot and what is the use of Bode plot, and we have also studied some terms related to Bode plot. And we know that Bode plot is plotted in a semi-log graph sheet, and it is a time response, it is a frequency response plot, and also we have studied that the Bode plot can be plotted for both open loop and closed loop transfer function, but here we consider only open loop transfer function for our simplification. Fine. So there is a problem which is given as sketch the Bode plot for given transfer function. And yeah, I want to add one more point that Bode plot is not a single plot; it is a combination of two plots. On the first one will be the magnitude plot, where the magnitude will be represented in decibel dB, that is 20 log g of j omega, and the second plot will be the your phase plot. The phase or angle will be in degree. So your x-axis or the horizontal line will be in frequency line, and your y-axis or vertical line for the magnitude plot will be in decibel, and for the phase plot it will be in degree. Okay, so here the transfer function or the open loop transfer function is given g of s equal to s square divided by 1 plus 0.2 s whole into 1 plus 0.02 s. Fine. So only g of s is given, that means it is a unity feedback. Here h of s is 1, and we can see in numerator we have s square terms, that means twice the s term in the numerator indicates the derivative. So here s square means twice the derivative or second derivative of the equations, and as in denominator 1 plus something s, that is a Bode form. So don't be confused that if it will be like something in some other form, you have to convert it into 1 plus something s. Okay, 1 plus something, that will be the best form for your understanding. Okay, so the sinusoidal transfer function or g of j omega is obtained by replacing s by j omega, that you know that, and when you replace s by j omega, we'll get that it is a j omega square divided by 1 plus 0.2 j omega into 1 plus 0.02 j omega. And the next will be, we need to find out the magnitude plot. Okay, so from the transfer function we need to find out the magnitude plot. Here we see that the frequency response transfer function or the transfer function related to frequency we get. So from this we can find out the magnitude value and also the phase value. So one more thing, we need to find out the corner frequency. The corner frequency, it is a term where the plot or the magnitude plot or phase plot both bend or turn. Okay, like so if you have a if your phase plot is going like 20 dB per decay, and if it reaches at the frequency and it bend, then it is called as a corner frequency. So obviously that the name indicate corner means it have a bend. So how to find the corner frequency? So if your terms, or if your denominator or numerator whatever, so it 1 plus something, then the coefficient of s or the reciprocal of the coefficient of s is the corner frequency. Here we have we can see you can get two corner frequency, that is 1 by 0.2 and also 1 by 0.02. So you can see here that two corner frequency, that is omega c1 equal to 1 by 0.2, that is 5 radian per second, and omega c2 which is nothing but 1 by 0.02 and it is equal to 15 radian per second. Remember, omega is always represented in radian per second. Okay, so in this case we no need to think about the hertz. I mean, in the if your unit should not be in hertz, the unit should be in radian per second, because we deal with the omega. Fine. So the various terms of g omega can be listed in table 1 in the increasing order of their corner frequency. Also, the table shows the slope contributed by each term and the change in slope at the kernel frequency that I need to show. So here I can get two kernel frequency, which is 5 radian per second and 50 radian per second. There might be chance for different problem you can get more than two kernel frequency also. So what your duty is, you need to find out the kernel frequency and arrange in increasing order like this. So the table should be of 4 column, and the rows should be number of kernel frequency plus 2. So for each term, we have a transfer function. Numerator is s square by 1 plus 0.02 s into 0.2 s. So we have 3 terms in the transfer function given. So for each term we need to consider. First, let us take the j omega square term. So in the j omega square term, it is not in the form of 1 plus something. So in that case, in this case, the kernel frequency does not exist. Okay, we have studied in the last classes that on previous class that when the numerator will be in derivative term, it will becomes like plus 20 dB per decay. So according to the nth order derivative, so that 20 dB will be multiplied with n. So here I have j omega square, that is second derivative. So 20 dB, I mean plus 20 dB into 2, that is plus 40 dB. So when you get j omega square, you do not have any kernel frequency, as because the kernel frequency comes from those terms which will be in the form of 1 plus something or 1 plus something s. So j omega square do not have any kernel frequency, but j omega square can contribute a slope of 40 dB per decay. Clear? Because only j omega or only s contribute 20 dB. So as your power increases, that 20 has to be multiplied with the power. So we'll get 40 dB per decay first. So we have started from j omega square, and do we have any change before that? Because we start from that. So if you start from some point, then how to predict the change before that? So we don't have any change of slope before that. Then with respect to kernel frequency, you need to put the term. So here lowest kernel frequency is 5, right, or 5 radian per second. So that we have to keep this term here, 1 by 1 plus 0.2 j omega. Okay. So with this, can you guess what will be the slope? The slope will be minus 20 dB. We have studied this thing. Okay. So if your slope will be minus 20 dB, and previously it was plus 40 and now it was minus 20, then what will be the change? Change is 40 minus 20. When you add these two, we get the change, that is 20 dB. पहले था 40, अभी हुआ minus 20. क्लियर? तो मतलब पहले था 40, अभी ऐड हुआ minus 20, तो हुआ कितना? Plus 20 बच गया. Okay, so that or can say you can if you try to understand in this way, you can see okay. So let me try to draw a straight line first. Okay, so in this straight line, first we have a slope which is plus 40 dB. Clear? And this is point, this is called corner frequency. Here the angle changes, and here I am getting minus 20 dB. What is that? Minus 20. So just imagine in this way, on the top side it is positive and the down side it is negative. Okay, so and the thing will be running with plus 40 dB per decay previously. When it reaches here, it added minus 20 dB. So what should it should not go like this, na? It has to be subtract 20 dB. So it will be like Let me draw once again here. Okay, so like this is the straight line, and we have, let's say, 40 dB, and in this point I am getting minus 20 dB. So what are the equivalent? If there is, if I do not add anything here, let's say it is 0 dB. So if it is 0 dB, then it should continue, then again with same slope it should continue. That means it should continue with 40 dB. But what happened before continuing in this point or in this frequency, it added a minus 20 slope. Okay, mark my word, it add a minus 20 slope. That means with plus 40 it add minus 20, so the slope now becomes plus 20. प्रीवियसली था कितना, 40 था. ओके, अभी माइनस 20 ऐड हुआ, इसलिए स्लोप यहाँ पे चेंज हो गया. फिर अगर यहाँ पे अगर फिर माइनस 20 ऐड कर दूंगा तो क्या होगा, माइनस 20 से ये 0 हो जाएगा, क्योंकि लाइक पैरेलल लाइन. सो 40 plus minus 20 becomes 20, 20 plus minus 20 becomes 0. So in this way you need to understand. So first it was having slope of 40 dB per decay. Then in this kernel frequency it added a slope of minus 20 dB. So when 40 dB is added with minus 20 dB, it becomes plus 20. Then with this kernel frequency it add another slope of minus 20 dB. So change becomes 0. So you can see that if you try to plot the graph, you can see when my Bode plot reaches with the kernel frequency omega c2, after that I can predict my line will be parallel or horizontal line. Okay, anyway, so we have found from the equation that we have only two kernel frequency, but the process says that after doing the tabulation, finding the change in kernel frequency, what we need to do, we need to design two more kernel frequency. Okay, one is omega L and another is omega H, a lower kernel frequency and higher kernel frequency. Remember the rule, the lower kernel frequency should be less than lower kernel frequency, and the omega H should be more than higher kernel frequency. So यहाँ पे मेरा एग्जाम्पल में we have two kernel frequency 5 and 50. So यहाँ पे लो कितना हुआ 5 and high कितना हुआ 50. So we need to choose omega L which should be less than 5 and omega H which should be greater than 50. So in this way we have to choose low kernel frequency or low frequency omega L and high frequency omega H, which should be omega L should be less than omega C1 and omega H should be greater than omega C2. Okay, here if your omega if you have more than 2 kernel frequency, same procedure also applicable. The omega L should be less than the lower kernel frequency and omega H should be higher than the higher kernel frequency. So that depends upon you what value we have to take. Let's say in this example we have omega L is 0.5 and omega H we have taken 100. So instead of 0.5 you can take 0.1 also, 0.001 also. Don't bother about that, because whatever you take omega L, it should be less than 5. So starting from 0.0001 up to 5 or 4.9, everything will be under 5. Similarly, our larger frequency will be 50. So above 50, what you take, that depend upon you. So omega H I have considered omega L 0.5 and omega H as 100. So with these two, we need to find out all the gains. I have two kernel frequency and I have added two frequency omega L and omega H. So I have total 4 frequency right now, and with that 4 frequency I have to find out the gain, and that gain should be in dB. Okay, so at omega equal to omega L. When omega value equal to omega L, then what will be my gain? Gain formula will be 20 log j omega square. Why here j omega square? So first we have choose the frequency omega, which is nothing but the omega L, and the value of omega, the value of gain has to be find out in 20 log s or 20 log j omega square. Why this j omega square? This is the magnitude, na? So remember, you need to remove all the terms which is in the like 1 plus something s. So let me go back to the this equation. You can see here all the things will be like this, s square divided by this and this. I told remove all the 1 plus something s terms. So we have two terms which is like 1 plus something s. After removing these two, we have only s square. So it depend upon your. So you may have s square by something or s by something. So it depend upon you. So you need to remove all this term first. Then after removing this thing, this value has to be considered. Okay. So please take care of this. So what happened? We need to put the value of omega L in place of j omega. So it is like j omega square equal to omega square, and because j equal to minus 1 into minus 1 equal to 1. So when 20 log 0.5 the square, you can get minus 12 dB. Okay, this is the first point we have chosen. Okay, and if you go for the second point will be omega c1, and when you put the value of omega c1, you can get the value of omega c as 20 log 5 square, which is nothing but 28 dB. So you can see from the first point to the second point, I told you the other corner frequency, na? You can see previously it was minus 12 dB and the second will be 28 dB. Can you guess what the difference? Difference is 40 dB. So here I have 1 dk. Okay, you need to choose you can see you need to choose this the omega L, so that it should be in 1 dk or 2 dk or likewise. Here previous the omega c1 is 5. So what will be the value before 1 dk? It should be 0.5. So likewise you have to choose. So can see when you changes the frequency point, you have a change of your dB, the magnitude, that is 40 dB. Okay, and next is important. This is important case. After finding this thing, see the chosen point and the lowest corner frequency point can be directly found. Okay, so what happened for the next? You can get a formula like this. The corner frequency at omega c, the formula will be slope from omega c1 to omega c2 into log of omega c2 by omega c1. Then add the gain at omega equal to omega c1. This is a long formula. So if you have basic knowledge of your geometry, then you can easily crack it out. Okay, let me make you understand with the diagram. So let's say I have the plot like this. Okay, try to understand with me. So this is my log plot, and this is frequency. Okay, in frequency in terms of log, and this is my a or gain. So first I have taken a frequency, I have taken it 0.5. okay, and I'm getting a value of minus 12 here. How much? Minus 12. Clear? Remember this thing? Then when I go for omega c1, or I can adjust omega 1, this is nothing but 5. In this value, I'm getting a corner frequency of, let's say, here I can take, let's say here, a corner frequency of 28. Don't bother about the scale. I'll just try to make you understand. Clear? So this is the point. So if you try to draw a triangle, right angle triangle, so what you can see, this is nothing but my P, this is B, and this is my H. Okay, so this much you know. What happened? What is the gain value for omega 2 or omega C2, second recurrent frequency? It is somewhere here. Wherever, I am assuming it is somewhere here. If it is somewhere here, then I can try to make a, as like this triangle, I can try to make a triangle with this also. Okay, I do not know what is the value. I do not know this value, but I want to find this value. See, wherever this value will be, I'll get a point over here. And if I join this line with the frequency and this the previous gain, this line, this previous gain, if I join, then I can get a triangle easily. This is not a rocket science, you can easily find out. Now can you see, this is a slope, yes or no? And we know that slope is equal to P by B or tan theta. This much we have know. Here slope is already given. What is the slope? Slope from omega C1 to omega C2. ये स्लोप प्रीवियस टेबल में हमको मिल गया था, इस स्लोप का वैल्यू जो कि -20 था. Yes or no? That is why I have created the table. Okay, so I know this value. Fine. Do I know this value, this length? No, I do not know, but I know this point, I know this point, and if I subtract this point to this point, then I can get this length. So can I subtract 50 minus 5? Yes or no? No, I cannot subtract like this, because this is not a linear scale, it is log scale. So I can write like log of 50 minus log of 5, which will be eventually becomes log of 50 divided by 5, and we can get log of 10. Clear? So I get this as a log 10. Okay, so this is slope, this one it is given, and this one it was from here and plus this, and you can see so to find this slope, okay, h, let's say it's h equal to this P divided by B. Okay, it's in trigonometric function. I just write like this, h equal to P by B. Okay, so I mean not h, it is tan theta, and tan theta is equal to slope, na? That is why this is slope already given, so I have written just h. Do not confuse. P by B is nothing but tan theta, and tan theta is nothing but slope, and slope is this line for our case. So we can write directly this h equal to P by B. Okay, if you have confused, don't bother about this, you can write s equal to P by B. Okay, what is the P here? P is this point minus this point, or what is this point? This is the gain at omega C2, and this point, this is the gain at omega C1. So A at omega C2 divided by A at omega C1. Okay, so this much you have clear na. So here I want to find out gain at omega C2. I do not know, but I know this one. If I know this one, I can do this exercise to find it out. So this slope when multiplied with this one will get some gain. Yes or no? This divided by this will give this. Or you can see this into this will give this. Fine. Okay. So when I get like this, okay, this is omega C2, this is omega C1. You can try the mathematics, no problem. So here I have gain like A2, and here I have gain as A1 or omega C1 jo bhi. So what is the value? I know this, I know this, I need to find this. So this is, if this is P, this is B, this is S, I can write S equal to P by B, or you can write P equal to SB, and S is the slope, this is, and B is nothing but a log function, this. Finished. Then why this? P, do I know P? Do I know this? No, I know only this point. I want to find this point. So what is the difference between these two? The difference is, I can write P equal to gain at omega 2 minus gain at omega 1. Gain at omega 1. This much, and which is nothing but this value. And I know this one, and I want to find this one. So this will come here, and after equality it becomes, this minus becomes plus. So I will get this formula. Clear? So I repeat. So when you try to plot, find the gain, first remove all the terms which will be related to 1 plus something s terms. The remaining term we have to take in between these two lines, that is the magnitude. So for omega L and for the lower corner frequency, you directly found this thing. Then for the next frequency or next corner frequency, you have to use this formula, or you have to use your geometry skill. So which will be lead to 48 dB, and for omega H, the next corner frequency will get that is 48 dB. So from the previous table, the table it is given like here, from this value to this value, I have a change, I have a slope 40. Then from here to here I have a slope minus 20. Then from here to here I have a slope minus 20. So पहले तक कुछ चेंज नहीं हुआ, उसके बाद 20, उसके बाद 0. So you can see here, first it was minus 12, then it was 28. So here 48 dB. Then I have to go for minus 20. So you can see here 28 plus 20, we have a change of 20 na. You have a 20 there na, change in slope equal to 20 here. Previously it was 40, now it was 20, then 0, change in slope, I'm saying change in slope. So it was saying 40 here, then 28 to 48 I have 20 dB per decay change. Then next change should be 0 dB, that is why next value will be remain as 48 dB. So here 0 dB change. So after finding all this gain, you need to plot the Bode magnitude plot. So to plot a Bode magnitude plot, we have to first take the semi-log graph sheet, and in the semi-log graph sheet we have to choose the you can see here na, here you can visible. So I am taking from 0 0.1, 0 0.2, 0 0.3, 0 0.4, 0.5, 0.6, 1, and 0.6, 0.7, 0.8, 0.9, then next decay, then next decay. So likewise I have drawn the scale. The scale is depend upon you how to draw, because we have to see the table. According to a table value, we have to design the scale. Then I try to make two graph in a sheet. So I have taken the upper half for magnitude plot and the lower half for gain plot. So I have chosen 0 dB is this line. Okay, this is 0 dB I have chosen. Then if I go up I have a positive, then if I go down I have negative. So for 1 unit I can change in y-axis 1 unit is equal to 10 dB. So here 0 to 1, this is 1 unit now, 1 gap equal to 1 unit. So 10 dB, 20, 30 likewise. After that, what you need to do, we need to plot the current frequency. Here the first current frequency, that is omega L, lower, which is 0.5, which we have chosen. Okay, the first current frequency will be the 5 radian per second. The next will be at 50 radian per second, and we have chosen another omega H, which will be 100 radian per second. So after finding all this current frequency, we need to point out the gain with respect to those current frequency. So for 0.5 we have a minus 12 dB. So this then for 5 radian per second we have 28 dB. Then for 50 radian per second we have 48 dB. Then also for 100 radian per second we have same 48 dB. So we need to find out the point, and after finding the point we need to join the lines. This line has to be joined using scale, and after joining the line you have to write the slope with respect to those lines. So first slope will be 40 dB per decay, second slope will be 20 dB per decay, and third slope will be your 0 dB per decay. You have to write, I have forget to write. Okay, so this is my phase plot which is completed. Now let me go for the previous one is the magnitude plot which is completed, and let me go for the discussion for phase plot. So for phase plot, I know from the transfer function I am getting the angles, the equation of angles, which will be 180 degree minus tan inverse 0.2 omega minus tan inverse 0.02 omega. If you understand this thing, it's well and good. If you don't understand, then study the PDF I have provided to you. Okay, so you recall the last lecture, so you can easily find out the angles. So the phase angle are calculated for the various value of omega and listed in table number 2. Okay, so here you can take all the value, use this equation. Remember, use this equation. Type this equation in calculator. If you do not know how to type, just listen my word, then you can easily type. First, set the calculator in a compound. Okay, so you know the normal calculator in normal, it will compound mode. How to do that? Press setup, then 1. So the normal mode will be here, this thing. Then what you do, you write 180, okay, then put minus, then tan inverse 0.02 omega. Okay, but omega is not in your calculator. We have x, y, those value. So wanted to write tan inverse 0.2x. How to write? Shift, then tan. Okay, if you write shift tan, you will get tan inverse. Then write 0.2 instead of omega you have to put x, and x will becomes, how to write x, you have to press alpha then x button. Find out where is alpha and where is x button in the calculator, then you close the bracket. Okay, so this is done with up to tan inverse 0.2 omega, then minus, again shift tan inverse 0.02, then alpha, here again x, because unknown is only one, omega. So if you take first omega as x, then second omega is also x, then close the bracket. Okay, after doing this, do not put equal to. Okay, what you do, you have to find out in the calculator, in the left side top second bottom will be written as CALC, calculate, then hit calculate or solve. In some calculator written as solve or CALC. So after doing this, you can see it is asking x and question mark. So you have to put the value of x as 0.5. Here x is omega. Okay, so after doing, then you can put equal to. So when if you do that, you can get 173.71, which is nearly 174 degree. Clear? How to find the next frequency or next angle with respect to omega equal to 1? Then again press without pressing anything, just press CALC or solve button. Then it was asking again what is the value of x, and it was showing that previously 0.5 is entered. Now you have to enter 1 and press equals. You will get 167.54 or 6, that is 168. Likewise, you have to find out this thing. Remember, you can ask me, sir, why you have chosen omega equal to 0.5, 1, 5, 10, 50 and 100. See, the omega here in this phase plot is smooth plot. The magnitude plot will be drawn using scale, but phase plot has to be drawn with freehand. So if you draw with freehand, then if your value should be near to each other, then it will be more satisfying plot. So you have to choose all the corner frequency. With respect to that, if you choose some more frequency, then you get a smooth curve. So 0.5, 5, 50 and 100 is my corner frequency, and I have chosen one in between. You can choose like 5, 7, 10 is already given, 30, 40, 80 and also. So as your frequency, different frequency have taken, you can get a good smoother plot. So if you by using the formula and with difference value of omega, then you can find the different value of phase or phi. And in the same plot, previous magnitude plot, then you have to plot the phase. So I have chosen the down part with phase. So in y-axis I have taken 1 unit is equal to 20 degree. So in the right side I have written like this: 0, 20, 40, 60, 80, 100, 120, 140, 160, 180. See, angle is not comes in negative. So I have taken from 0 to 180. Now with respect to all corner frequency, I have to find the point. So this will be the first point, which is around 178. Then second corner point with 0.5. Likewise, I have found all the points, and after finding all the points, I have to join the line. This is smooth line. This is not join using scale. The previous magnitude line should be joined using scale, but this phase line should not join in scale. It is a freehand sketch. So as your number of frequency term increases, you will get a very smooth line. So this is all about drawing and the Bode plot, and this is not over yet. So from this Bode plot, we have to predict many more things, that is gain margin, phase margin, gain crossover frequency, phase crossover frequency. So let me toss this all the terms. what is gain margin? What is margin first? If your notebook and see, you have put a margin line. That means after the margin you start writing, but there is a margin for some time. If you want to use, then you can use, but after, if you use the margin also, then you cannot able to, you will go to the next page. Similarly, let me give an example of a power plant. If your power plant is providing, let's say you have a power plant, thermal power plant, which is capacity of 100 megawatt. Okay, the plant capacity, it cannot produce more than 100 megawatt. Finish, maximum 100 megawatt it can produce. But if that power plant is connected to a load which is of 80 megawatt, I mean the maximum load demand which has to be connected to the power station is 80 megawatt. So we have 20 megawatt surplus, that is the margin. That means it is already available, because in power plant the generator is rotating. Okay, the generator is producing power, it is producing 100 megawatt power, but my load is using only 80 megawatt power. So 20 megawatt is surplus power that can be accessed whenever you have a demand. Okay, so that is surplus power. But if your demand increases beyond 100 megawatt, can the same system or same power station will able to supply? No. When your system, that is many things in the power system things. When you study power system, you can understand. But this is the margin. So what is gain margin? The extra amount of gain which you can use without the system go to system on verge of instability. Okay, so that much k value. What is the gain margin? What the k value you can adjust so that the system is in stable state. After that, system becomes unstable. Similarly, phase margin. What is the angle value you can change so that the system will be stable? After that, it will becomes unstable. So those are called phase margin and gain margin. Then we have phase crossover frequency. Then we have gain crossover frequency. So that is the frequency where the system becomes unstable for phase and also for the gain. So that will be studied one by one. This is for today class. Thank you very much.